So this video will touch on the volume of right prisms and cylinders. So a right prism is something like a cube, a rectangular prism, a triangular prism, a trapezoidal prism, all of those ones. And then we'll also do cylinders as well. So firstly, you need to understand what volume is. Now, volume is measured in cubic units. And what that means is we're trying to figure out how many little cubes fit into a 3D shape. So basically, we're trying to find the space on the inside of a three-dimensional shape. Now, to do that for right prisms, we have a general formula, which is V is equal to A times H. Now, it's important to understand that A is the area of the base. So what that means is whatever type of prism it is, so if it's a triangular prism, it's the area of the triangle. And then we multiply it by the height. Now, sometimes that height is also the depth. And what that means is it's the length that joins the two prism faces. So what that means is if it's a triangular prism, it's the length that joins the two triangles together. So what we'll do first is we'll start with a cube because that is the most simple shape. So if we're looking to find the volume of a cube, now if we're looking at that general prism formula, we need the area of the base. Now, the area of the base is this shaded section here, and you'll notice that we do length times length to get the area of the base there, to do the area of a square. So straight away we're going to have volume is equal to length times length, but then we also have to multiply it by that height. So in this case of a cube, because they're all the same size, we just do the volume is equal to length cubed. So for this example, we would have that equals 4 cubed, which is 64 centimeters cubed. So the volume of that particular cube there is 64 centimeters cubed. Pretty straightforward, that one, and quite simple. So we'll move on to rectangular prisms, which is very similar. So if we were to label this, we would have the length, the width, and the height. Okay, again, it doesn't really matter which way you label it. I just tend to label the length one way and then the width the other, and then obviously the height is top to bottom. So then if we do the area of the base for this one, it's a rectangle. So it means we're doing length times width. And then our formula says we do the area of the base times the height, which means it would be length times width times height. Now, in the formula, we don't write multiplication signs. It's just to keep it neat when we actually do our working. So for this one, I'll write 11 times 8 times 4. We have to make sure that we put our multiplication signs in. So then we would get the answer to that as 352 millimeters cubed this time. So we'll move on to triangular prisms. So this time, the volume is area of the base times the height. So what we're going to have here is we've got our base of our triangle, our height of our triangle, and I'm actually going to label this the depth this time. Just because we've already got a height on the diagram, it can get a little bit confusing. So if we're doing the area of the base, we're doing half the base times the height, because that's how we find the area of a triangle. And then we're also going to multiply it by that depth. So if I was to do this example here, I would be doing half times 8 times 6 times 14 to get an answer of 336 millimeters cubed. So again, all I did there was find the area of that triangle and then I multiplied it by the depth. Now, it's important that you do remember that the area of the base or the front is that whatever type of prism it is. So we'll move on to a little more challenging one now, which is the Trapezium Prism. And now the only reason this one is a little bit harder is because sometimes people don't recognise that it's a trapezium. So we have to go right back to what makes a trapezium a trapezium. Well, there's two things. It needs to have one pair of parallel sides and 4 sides to the shape. So it needs to be a quadrilateral with one set of parallel sides. So you can see here on this diagram, the 5 and the 13, they run parallel to one another. So we need to figure out our area formula. We need to remember our area formula for a trapezium. So firstly, we're going to write volume is equal to. We're going to label a few things here. So I'm going to label 5A and 13B. And we always label A and B the parallel sides. Then we also need the height of the trapezium. It has to be the perpendicular height. So I'll label that 7 as the height of the trapezium. And then again, because we already have a height involved, I'm actually going to label this 4 centimetres the depth this time. So area of a trapezium is half of A plus B, remembering to put our brackets in because we have to do the addition first, multiplied by H, and then, so that part there is the area of the trapezium, and then we're going to multiply that area of the front there by the depth. So for this example, we would have half of 5 add 13 times 7 times 4, which gives us 252 centimetres cubed. Remember to put your units in, and remember it's cubic units for volume. So our last one is a cylinder. Now for a prism, it's a special type of prism because it doesn't have straight edges, but we still see it as a prism because it has the same front and back. So they're both circles. Now we need to do the area of the base, which is a circle. So to do that, we would do pi times the radius squared, and I'll just label that 6 there as the radius. And then we have to multiply that by the height of the prism. And again, that 11 centimetres is going to be the height. So for this, I would have it as pi times 6 squared, remembering to put my multiplication signs in, times 11 to give us 1,244.1 millimetres cubed to 1 decimal place. And it's just important to remember with a cylinder that sometimes you're actually given the entire diameter of the cylinder, and it's really important that you don't use the diameter because in the formula there is no room for the diameter. It says the radius, so if you're given the diameter you need to find the radius first before you can start. So that's basically all you need to know for volume of basic shapes, and then you can move into more difficult shapes a bit further along, but I'll just quickly go through some capacity things now. So capacity is just the liquid measure of volume, so they're really closely linked, and capacity is measured in like millilitres, litres, kilolitres, there's megalitres and gigalitres, but we tend to only work with these 3. So the good thing about changing units with capacity is going from millilitres to litres or to kilolitres, it's always by 1,000 because there's 1,000 millilitres in a litre and then 1,000 litres in a kilolitre. The other thing that you do need to know though is that for capacity, to be able to change something from volume to capacity, so this is to go from volume to capacity, what we do is we need to know these things. We've got 1 centimetre cubed, so just picture that 1 centimetre cubed in your head, and that 1 centimetre cube actually only holds 1 millilitre of water, okay, or 1 millilitre of liquid. Then we have a metre cube. So again, picture that size difference there of a metre cubed, and a metre cubed holds 1,000 litres, which is the same as 1 kilolitre. So when you think about it in terms of that amount of liquid, if you think about the milk bottles that you would normally buy, they're 2 litre milk bottles. You could fit 500 of those poured out into a metre cubed. Okay, so when you put it into that sort of perspective, that's quite a lot of liquid. So I'll just quickly do an example using one of the ones that I did previously. So if we have a look at this trapezium prism, the volume was 252 centimeters cubed. So I'll just go back to our capacity. So we had volume is 252 centimeters cubed. If we're trying to find the capacity of this, say in milliliters, that's an easy one because 1 centimeter cubed is 1 milliliter. So that means it's 252 milliliters. If you were then asked to put it into liters, so I'll go up here, in liters, it would be, we would do divide by 1,000 using our chart from here, and we would end up with 0.252 litres. Okay, so it's just about changing from the centimetres cubed or metres cubed to millilitres or litres or kilolitres and working from there. Sometimes you're asked to put it in the most suitable units. So, for example, this one here, I would just leave it in millilitres unless it's otherwise stated. But if you got something like 57,000 millilitres as an answer, you would probably change that to litres and make it 57 litres. And that's all for volume and capacity at the basic level.